Hello.
Uh, uh, Hello, and good news. I've managed to switch my mic on. Apologies for that. Welcome to another Big Data London webinar. I'm Andy Steed, Content Director of Big Data London, and I'm joined today by Christopher Bergh from DataKitchen. So as for anybody who's been to the physical event, they know that DataOps is an integral part of the Big Data London program. We cover it extensively. We in both our theatre and our tracks and online. And today we're delighted to have with us Christopher Bergh, who's going to do a nice presentation for us about his thoughts. Thank you, Chris. Nice to meet you finally.
Oh, thank you, Andy. Welcome. So I have a talk today. So I have some slides to share. So if you don't mind, I'm just going to go share my screen and kick off.
Perfect. Thank you.
So Andy, hopefully you can still hear me. So my name is Chris Bergh. So I run a company here in Boston in the United States called DataKitchen, and we focused on bringing the idea of DataOps to market and have a software product to support that. And so there's a couple of sort of big ideas in data and analytics today. I think everyone's heard of the cloud and Google and AWS and the transition, and Andy Jassy taking over, the AWS CEO taking over Amazon. And so I'm going to talk a lot today about the DataOps in the cloud and how the program of the cloud is really in some ways a DataOps program. And to do that, I'm going to talk about data and analytic tool chains. That's all the pieces that you put together to build an analytic system. I'm going to talk about how DevOps and workflow tools just don't make the cut. And then I'm going to give some examples of sort of a DataOps superstructure and how that works with some of our customers. And so, yeah, I've been in the data and analytic field for a long time, and I've seen a lot of data and analytic projects fail. And I'm going to use the term data analytic in this broadest possible sense. It could be a data visualization. It could be a neural network. It could be data preparation or data governance. It's everything related to getting value from data to an end consumer or to a business person. And a lot of projects are failing. In some ways, 60% of all data and analytic projects fail to meet requirements or make customers successful, according to Gartner. And so why is that? I think in a lot of ways, people have tried to go and use technical means to fix a people and process problem. And I think the move to the cloud is another case in point, in that if you take your data and analytic work, a database, a model, a visualization, and try to get it on the new tool chain in cloud, it seems to be the cool thing. Like 70% of IT decision makers want to migrate to a cloud data warehouse. Snowflake has got a valuation of 190 times revenue. And, Forbes thinks a third of all IT budgets will be focused on the cloud, which is an amazing transformation. And I'm not dinging the cloud in any way. But I think really, if we look at it beyond the sort of accounting things of why you would want to go to a cloud instead of having something being a fixed cost to a variable cost, the real hope is that you can increase agility and reduce the time it takes to get the ideas from the brain of your data scientists into production. And so I think the challenge with that is that even people who are moving to the cloud are spending sometimes years building cloud architectures before they actually see any value. And what happens is they end up recreating the same kind of people and process problems they had when their servers and software were on-prem or in the cloud. And yes, the cloud offers you the opportunity to spin stuff up and spin stuff down, which is all really cool. But you still end up having the same sort of inflexible data architecture, the same kind of bottlenecks, still building a lot of technical debt, and still taking a long time to get things into production. And when it's in production, having a lot of errors. And so, I think the transition to the cloud doesn't actually solve these problems, which are invariant of the substrate that you do your work. It could be on the cloud, it could be on-prem. And so, what we've done is done surveys with groups like Eckerson and try to answer, like, how long do people take to deploy new analytics in general? How many errors do they have, either from poor data quality or things going wrong or being late? How often are teams at odds with each other or just spending too much time in meetings? And what we found is that it's actually not great. Even when people have moved to the cloud, their cycle time is low, their error rates are high, and the amount of collaboration they have to take is worse. And sometimes it actually gets even harder because you're taking something that worked on-prem and trying to recreate it in the cloud. So you've got two versions of the same thing for running for a while. And so, our feeling is that the transition to the cloud is while wonderful and has benefits, doesn't really solve the biggest core issue in data and analytics. And DataOps, this idea of focusing on cycle time, focusing on lower error rates, focusing on how your team collaborates across all your people and technology and data sets, and then actually having clear process measurement is really the set of technical practices and cultural norms and architecture patterns that you need to do to go and be agile, to run a successful data and analytic teams moving forward. And I think the market is starting to kind of believe in that. There's tracks, there's words. In fact, the word DataOps was almost unknown. 4 years ago, we actually authored the very first Wikipedia entry on the term DataOps. And so I think it's it's getting to be standard practice now, or at least these ideas are. And mainly they come from they don't come from DataKitchen. They sort of predate. They come from manufacturing and software development. These ideas of lean manufacturing and DevOps and Agile are all applied to data and analytics. So I guess the first point is your cloud migration program is actually a DataOps program, because the goals of it, beyond changing the accounting costs of how you use things, is that you're really trying to get agility, trying to deliver things faster, trying to make your customers successful and have them trust the data with low errors. And so let me talk about, just in general, these data and analytic systems, because they are really complicated. And so if you look at one perspective, and every data architecture is different, but they all sort of have the same design, in that there's data on the left side and sort of data customers on the right, and there's a series of steps in the middle. And data on its journey kind of goes in a database, maybe goes in a blob store, maybe goes in some kind of analytic database. It's transformed in some way, ELT, ETL, MapReduce, Python, SQL. It's actually may or may not be run into an engine that does a model on it, maybe a k-means cluster, a segmentation. Maybe it's visualized in Tableau or Cognos. And finally, it's governed, meaning it's put in a data catalog tool. And if you look at each one of those tools, there's actually sort of 50 vendors in each category, and they're all have some cool things associated with them. Some of them are newer and older. Some of them are more suited to someone who has less technical skills, who can't code. Some are more pointed towards people who can code. And so every cloud vendor over the past 3 or 4 years has kind of assembled their own version of that tool chain. So they all have analytic databases, they all have blob stores, they all have ways to transform data, sometimes multiple. They all have data science toolkits. Some of them have built their own visualization. Some have bought companies that do visualization, and they're trying to have that whole stack that's available for you to use. And so it makes it complicated, right, in terms of what you do, because also in every one of these people, they have vendors who offer their version on the cloud that you can turn on. And so let's just take a look at all the tool chains out there, at least 6 of them. So let's pick Amazon. It's got the biggest market. And so if you want to put things into Amazon's Redshift, well, you got to get into S3, which is a blob store. And then if you want to stream data in, well, they've got Kinesis Firehose. If you want to do ELT or ETL, they've got Glue, and also they've got Managed Airflow. They've got SageMaker as their data science tool. They've got QuickSight as their BI tool, and they got Glue Data Catalog. So they actually have everything that you want. Now, if you go to Azure, you've got another set of things. You've got, for instance, Synapse, their database, or ADSL, their Azure Data Lake storage, Event Hub, Data Factory, And then if you go to GCP, you've got BigQuery and GCS and Google Cloud PubSub. And so there's the equivalent of all those things in every one of the three vendors. But if you look at some of the more traditional vendors, like for instance, IBM Cloud Pak for Data, which they've taken all their tools and put them into a Kubernetes cluster. Or you look at the traditional big company on-prem stack, which is sort of Teradata and Informatica and SAS and maybe Cognos. And then you look at open source, there's a complete stack of open source tools that do almost the same thing. And so as you're picking, and then you go to all the vendors out there, right? So when you're building your data and analytics system, you're sort of designing a tool chain and you want to put those together. But also in the cloud, you've got supporting tools. So if you know, if you want to do data ops, that means that you're interested in the code that these tools create, and that has to be put somewhere. So that's stored in Git. And then you've got a way to store the passwords, which is called a secret store. There's a Kubernetes cluster, and there's these sort of EKS or AZS or GKE, which are sort of different versions of Kubernetes clusters in each one of these environments. And then a single sign-on provider. And so if you want to build a system in all these, you've got to integrate all these tools and integrate all these supporting tools. And even beyond that, you've probably got layers of the servers that they run on and other associated items. And so let's say you're going to work in it. You got to pick your stack. So which stack, right? What tool chain you're going to use and what supporting tools. And so you've got to put all these things together before, in order to start thinking about how to manage the cycle time and error rates and collaboration on your system. And so kind of doing data ops on Azure or AWS or more, it does have a powerful collection of data tools. And there's really no defined process because you've got to sort of put together the system that has it all working. And they really work to integrate the data, but not the processes that act on the data. And it's pretty overwhelming that we've seen from customers to try to design a data ops solution out there using these tools. And so what we're going to do next is saying, I'm going to the cloud. Cloud's got some of these DevOps tools. Maybe I should just use these DevOps tools and workflow tools to do data ops. And so I'm going to talk a little bit about why that doesn't work and what we've seen from some of the people who've attempted to do that. And so I guess the one way to think about it is what we're going to do is kind of think about how to put a data ops solution together on the cloud, and then compare that to the way that you really need to do it. And that breaks up into 6 categories. So the first part is something called an end-to-end meta-orchestrated production pipeline. And then the second part has got really the world's worst acronym, the DataOps C-SMOIDM, as opposed to DevOps CI and CD. So we're going to compare those two concepts. And then the third one is the lack of an environment pipeline. The fourth is sort of the fact that in data and analytics, there are complex teams and data centers. And then fifth one is about vocabulary, and sixth one is sort of process measurement. So let's talk about that. So given all those tools, right, the data tools, the ETL tools, one of the biggest problems that we see is the Friday afternoon scare that comes into data and analytic teams when the VP looks at the report or gets some data set and this is just wrong. And then suddenly everyone's trying to scramble to find out where the problem is. And is the problem in the source data? Was it in the streaming ingestion? Was it in a batch ETL? Was it in the data warehouse? Was it in the model? Was it in the visualization? And then each team owns different pieces. And so what happens is teams are scrambling at the last minute, spending all weekend sometimes trying to find out where the problem is. And then, you know, the challenge with that is no one knows where it is, right? It's these largely disconnected islands that have no bridge between them that allow you to make sense of what happens. And so there is no way to what we call meta orchestrate all these tools. And so because there's no place for them to plug into. And so they're still largely disjoint islands. And in some ways, what you need is sort of a DAG of the DAGs, or something that sits on top of it that allows you to sort of monitor, observe, and coordinate all those pieces. Really, I think for the first case, just so you know when there's a problem and you know it before your customers see it. And I think that's a really important part of building a data ops system, is to have that sort of system level view, and just don't hope that the data's right and hope that things, observe it, test it, meta orchestrate it. And tools like Airflow or Control M, while they do have workflow capabilities, they don't have all the tool plugins. They don't have the testing to be able to do that. So the second point is really this world's worst acronym. So I think if everyone who's done has a DevOps background, there's something called CI/CD, which is continuous integration and deployment. And what that means is when a developer on a software team checks in their their JavaScript code to the front end of a web application, it goes in through a process where it's integrated with all the other code that all the other people have done, and hopefully tests have been applied to it. And then it's deployed, sometimes automatically or sometimes manually from a development environment to production. And the idea of continuous means it happens automatically or at least quickly. And so in some organizations, a developer who's 2 weeks out of school makes a change to a JavaScript library, and then enough tests are applied and enough automation is applied that can automatically get into production very quickly. While I think one of the biggest perspectives is that what software developers do is very different than what data engineers and data scientists and people who do data visualization do. And so CI and CD is not really applies a little bit to data and analytics, but there's actually a wider lens that needs to be applied. And so we've coined this acronym, DataOps SMOIDM. And so it stands for a couple of things: continuous self-service sandboxes, because the role of data is incredibly important in data and analytics. Continuous meta orchestration, which we talked about before, continuous integration and deployment, which fits the same paradigm, and then continuous testing and monitoring. And so, one of the most important things that ideas that we think about is that every one of these analytic systems that you have in production has to be monitored. You have to grab little bits of the data, grab little bits of the artifacts, the model, the segmentation, the visualization, and test to see if they're right, and be able to check the data, check the artifacts by actually grabbing the data and looking at it and saying, is it right? How does it compare to last time? Is it increasing? Has it decreased suddenly? Is it the right shape, the right size? And be able to do this thing called statistical process control across it. And so those actually end up being equivalent to a bunch of tests that you write on top of all the tools. And so those tests actually perform a double duty, in that those tests that you run on top of your Azure Data Factory or Airflow or your Python model, they actually work really well in development as well as in production. And that idea of regression testing, functional testing, performance testing, and using those same tests in both ways, I think is actually a really important idea, because that way you can prove in development that what you've done in development works, and also that you haven't broken anything. And a lot of data and analytic teams kind of function with blinders on. They go in and they make a change and they sort of hope it works. And maybe toss it off to somebody else, and they have to figure out in a manual way, or they pass it on, and then the customer finds out there's a problem. And so take off your blinders as a data engineer or a data scientist, see the whole system. And to do that, you have to meta orchestrate the whole system, and you have to be able to test across the whole thing in development. And so that's another aspect of this world's worst acronym, SMOIDM, is that you're trying to continuously test in development and in production, and that those tests, those observations that you're making of the data going through the pipeline, in production, your data varies, but your code is fixed. But in development, you have test data, and that test data is fixed, but your code varies. And so another thing that's interesting, because in software development, one of the tenets of Agile is that you're kind of don't know what your customer wants, right? And if you take your web app and you put it in front of them and allow them to play with it and then iterate, you're going to end up building a better web app, and you're going to end up saving time. And I think that's actually still true in data and analytics, right? I think it's great, and it's very important that you put the data set or the report or the model in front of your customer, get it 70% right, and iterate and learn from it. However, the other part that is actually hard in data and analytics is that the data side is really important. And you may have the greatest way to visualize the data, but the data itself may not be able to express the idea that your visualization has told. And so as data engineers and data scientists, we're kind of caught between the rock and the hard place. And so what that means is the data that you use is incredibly important. And the environment that you use to develop it in or to run it in is really important. And so the ability to kind of create sandboxes that have the appropriate data, maybe it's production data or a filtered subset of production data, and all the software and configurations and hardware and access control is actually really hard. And it's also doubly hard because the people who want to access those kind of sandbox environments are often not very technical. They're not software developers. They may be your self-service BI people or someone who is a data scientist who's coming into the company for a few weeks to do a project. And so, a lot of times people think, okay, when we're talking environments, we're talking infrastructure as code. But what we think is that you need to bring together the appropriate data set, all the tools, all the software, all the people, and all the branch of the code that acts on those. And that's a lot of things that you've got to bring together, as well as being able to, in the cloud, kind of turn it on or turn it off in an on-demand way. And that sort of environment setting up and environment closing, it's just much harder in the data and analytics world. And it's much harder because the people who are the customers of that often don't want to learn 3 or 4 scripting languages like your software developers do. And so all these things sort of have to come together in your environment pipeline. And that just doesn't, Puppet and Ansible and Terraform are ways to abstract it. They're tools to handle just the sort of servers and software, but don't handle the data part or the Git part or the people part. And so the fourth challenge here is when you're working in the cloud, you often have something still running on-prem. And so a lot of us are in this sort of cloud transition, right? You maybe have a data warehouse or some servers, back in your data center. And the last year you said, okay, we're going to go all in on Azure. And so we've got Synapse and Databricks and Power BI running. And we just want to transition it. We want to get the stuff that's there running. And so maybe it's a big Teradata data warehouse. And so, one of the big mistakes I've seen companies spend a year and a half kind of building infrastructure in Azure and not delivering zero value. We came across one company that had a 400-person team working and building the infrastructure to do cloud analytics in Azure. And over a year and a half, it delivered zero value to their customers. They were just building things and trying to get it right. And so while that's great for that 400-person team, they get to learn a whole set of new technologies and buff up their resume. It's not great for the company that they still hadn't, they'd taken all that effort and still the entire company was based on the analytics that were sort of being barely held together on-prem. And so when you do any transition, what it means is you've got to run things that are on-prem and run things in the cloud in parallel and be able to shift across each. And so being able to work across these and actually being able to run parts of your jobs on-prem and parts of your work on the cloud, I think are very important because you have these different teams and different data centers that need to be coordinated. And they need to work in a coordinated way, but they also need to work in a separate way. So they need their own autonomy. And that also comes out in this case of that's very common and not unique to the cloud is the great centralization and versus freedom debate in data and analytics. And a lot of us have seen cases where there's a data warehouse team or a data lake team or a data enablement team that works basically in the home office. And maybe they work for the CDO or the CIO, and they're trying to build a resource for the enterprise to use. And they try to put all the data in there. Maybe they master it. Maybe they build a bunch of facts and dimensions. And then there's multiple sort of local teams using nice self-service tools like Alteryx or Tableau to kind of do some data prep. And the end customer, just like in the case where you're running on-prem and in the cloud, sees the result of both those coordinated together. And they have no idea that the report that they're using was built by one self-service group in New Jersey, and another report was built by another self-service group in California, all based on a database built by a team in St. Louis. They just don't know that. And so when something goes wrong, they complain. And then the problem is those teams in 3 different locations want to work independent of each other, but the result of their work needs to be coordinated. So how do you tackle that problem and not just sort of throw up your hands or solve it in another way, which is let's have a bunch of meetings and checklists and process. And so what we believe is that it's really important for you to have autonomy, but also have control. And so what that means is each group, whether it's the home office or each team, should have their own ability to orchestrate or meta orchestrate all their tools. And those pieces should fit up into a higher structure so that you can then get visibility in terms of when I make a change centrally, I want to be able to see if something's broken somewhere else around the world. And I've run into organizations that have data warehouses and thousands of reports scattered around the world, and they can't change anything in their data warehouse because they just don't know what's going to break. And that sort of situation is just very, very hard to control. And then the central team ends up getting blamed. And so I think being able to tackle this is an important part of being able to orchestrate across clouds or orchestrate across environments. And so part 5, I've spent sort of 15 years working in software and then another 15 years working in data and analytics. And while we sort of talk alike and look alike and watch the same movies, your typical data engineer and data scientist is not the same as your same software engineer. And so in a lot of ways, your software engineer doesn't mind stitching together a bunch of tools because that's their business. They like to write snippets of code, and maybe they know Python or Bash scripts, or picking up a new tool for a software engineer is something that is exciting. Whereas I don't know if that's the same case, maybe some data scientists or data engineers, but largely they're actually more outward focused. They're focused on, am I delivering business value to my customer? And so I think it's important in these systems that everyone have, not that the data engineer and the data scientist not have to master 7 or 8 tools and a couple scripting languages and the intricacies of Git to do their job. I think that's mainly the headspace of software engineers. And I think your data scientists don't want to do that. They want to focus on delivering value to their customers. And so having a sort of a common vocabulary and a common system, I think is really important for these people, just because they're different. And so in a lot of ways, creating this overall sort of system level view and management level view is kind of impossible for a lot of teams. They don't even try. So they end up saying, okay, well, I built some stuff and I'm going to throw it over the fence to someone else, and maybe it'll break, maybe it won't, maybe they'll call me up, maybe they won't. And just hear these horror stories of, oh yeah, some reports were broken in production for 3 months, or the one guy told me a story of sitting at his kid's birthday party on Saturday on the edge of the tub in the bathroom with the door closed, fixing a data bug. And I think it's to me, I guess I've been around the block enough that I just don't want that to happen. And I think that actually makes for a very difficult lifestyle for people who do data and analytics. And so I think, I think there's a lot of different people in data and analytics organizations. There's a lot of different tools and a lot of different ops that they need to do because they each have their own way of working. And so having a common sort of platform that all those tools can plug into, I think is the solution. And so kind of going to the last case. And so having a way to apply analytics to the work that your team is doing. And so all of us sort of get up in the morning and sort of, pour the idea of being data-driven on our breakfast cereal, right? We believe in being data-driven. We want our customers to be. We want people not to make intuitive decisions. We want the power of the data shown, and we want that to make a difference in our customers' lives. And the ironic part is that most organizations I talk to, the people who are managing teams of 30 people or 300 people, they are largely fairly unanalytic about what their teams do. They don't know, for instance, what their sort of status of their current production build is, or which data provider has been giving them problems. How is that? They don't know if their data is right. They don't have any tests that run automatically in production. They don't know whether they're meeting their SLAs. They don't know whether their models are actually still performing adequately. And so these sort of production metrics, I'm astonished that most people don't know. They just sort of hope it's working and wait for people to yell at them. And then in terms of their productivity, they may have 100 people or 200 people working for them, but how often are they deploying? How often are they collaborating? What's the individual productivity of the person? How many tickets are they writing? Is that increasing? And so I think being analytic about the work that your analytic team does, I think is incredibly important, because it helps you manage that team to metrics. It helps you understand what's going on. And also as a leader, it actually kind of makes you look good, right? Because you've got these cool management reports that you can show your boss or your boss's boss. And we've had plenty of customers come and say, I want the report. How many tests do we have running every build? And we have 1,000 tests running or 1,200 tests running, and they bring it up in reports with their with their end customers, saying every time we do it, we run 1,000 tests on the data, unique tests. And I think that's an important. In some ways, it can actually enhance the status of your chief data officer by sort of running a metrics-driven organization. And by and large, it's ironic, but most data organizations don't. They're off doing different things and not actually doing these key sort of product, project, or team or production metrics. And I think that's actually the key to change, right? Because it's a people and process problem, and people sometimes have a hard time changing. And one way to change data people is to actually show them the numbers. So I'm gonna switch to a different topic, because I think we talked a lot about sort of why DevOps tools and workflow tools fail at DataOps, or why it's really hard to be able to sort of do DataOps given the sort of tool chains that exist in your cloud providers. And so, what that means is, some people come in and say, wow, I've got everything. Amazon's got everything. And oh, look, they've got all these individual pieces too. They've got some DevOps tools. They've got a Get equivalent. They've got all the analytic tools. I'm going to just use that. And so what we've seen is that sort of superstructure that sits on top of all those tools is really what's needed. And if you don't have that superstructure, you're going to end up being like that company that has 400 people who ends up sort of spending years building it and not delivering any value to your customer. And so there's just a bunch of capabilities that we have talked about. So for instance, automated testing, both in development and production, being able to orchestrate across all your tools and deploy, and more than deploy, do the CSMOIDM, not just the CICD. Meta orchestration, being able to handle self-service sandboxes, and all these things, and sort of monitoring and process analytics. All those things I think are difficult because they're hard to do, or they actually end up being software development projects that you have to build in the cloud. And so from our perspective, that there's a superstructure that's needed. And it's a picture on the right of sort of a superstructure of a building. It's a thing that holds all the floors together. So you can then put on the walls and the windows and run the electrical wire. And I think that superstructure is really needed for doing DataOps in the cloud. In fact, for doing any analytics in the cloud. And I think we talked about a couple of these things. And just to repeat, the first is this idea of meta orchestration. And the idea that you have an analytic tool chain. It's composed of a bunch of tools. And how do you make sure that all those tools are running, that they're giving the right data, that they're not throwing off errors? And I think I think that's a very important part. And then how do you actually test those, both in development and in production, to make sure the whole system is working? And then being able to create sandbox environments, both in development. In fact, just abstracting out your development, test, production environment, making it easy to move the work that you do from one to the other. And then being able to have sort of a common way of collaborating and to kind of reduce the sort of surface of complexity for your data and analytics people. And then finally, measurement. How do you actually measure deploys and timing, et cetera? And so, one way to look at this, and I'm a technical guy, is sort of to look at it from how would you do this on Azure? And I showed this a bit of a diagram like this at the beginning, where there's sort of data on the left, and then there's customers on the right, and then there's your development environments: dev, task, UAT, pre-prod, production, and then there's the tools that you have. For instance, ADSL, the Blob Store, Azure Data Factory, maybe you have Databricks, maybe you have Power BI, maybe you have a data catalog, and then you want to deploy and you want to manage. And so all these pieces that you need to put together, all these little icons that you need to create and run, you have to actually build all this together to do DataOps. And our argument here is that it's not worth it, that it's, you're going to end up building a sort of a software team level development activity to make this work. And you're going to end up taking shortcuts. So for instance, another failure pattern I've seen in people who use the sort of DevOps approach is that they do a unit test in their data transformation. So they create some fake data in a table, they run the unit test, they say it's right, and then the data engineer sort of slaps their hands and says, hey, I'm done. And then it's thrown over to maybe the test environment, and then they find out in production it doesn't work. And if I would tell to a software engineer saying, okay, I just did a unit test and now I expect it to make it all the way to production, a software engineer would sort of laugh at that and say, no, a unit test is just a quick test to make sure it's right. It doesn't test the whole system. It doesn't test its relationship to other pieces. It doesn't test it with real size data. It doesn't test it in a performance way. And so I think that's why I think you need to be able to see the whole system in development. You need to be able to say, make my change, take your blinders off and see that, hey, this little change that I built works, but then see the whole specter of it end to end. And that's, and then be able to deploy it from one environment to the other. And so, it's trying to look at the differences here between trying to put it together and trying to sort of build it yourself, and just sort of walk through. And I won't go through each one of these because I talked about them, but sort of a checklist about what you have to do, and that come in a sort of a cloud tool chain and what happens in the DataKitchen platform. And so let me talk through a few examples. So to give you a sort of a concrete case of this. So here's a very, very large health company, sort of top 10 in the world. And they have a complex data landscape, right? They had sort of a Texas data and analytic team that had sort of built this incredibly large Spark cluster over the last 7 or 8 years that's on-prem. And they had a best of breed tool chain. They'd sort of done all the great tools sort of circa 3-4 years ago. And they'd found a use case, very high value drug development data. And then they had a different team that was in Azure, and they were sort of using ADSL and Databricks and other databases. They had an Azure tool chain, and they also had some various research data sets, and they kind of weren't talking to each other, and they weren't working. And so, like, one case was just what happened is the data in the Texas team was being sent over to the Azure team. And of course, Texas was making changes and Azure was using that data. And so how do you just make sure that when the Texas team made a change to the data and it was being pushed up to a bucket store, that the schema was right, that the data didn't change significantly? So if someone was using it in this cloud, they knew about the problems ahead of time. And they were discovering these problems in an ad hoc way. And while this case of sort of just moving data from one place to the other and making sure that the other team has tests to make sure it's right, it may seem small. It's actually a good case to talk about DataOps in the real world. And here's sort of an example of sort of the drift in the schemas that were caused by it. And it ended up just being lack of trust, and sort of the teams were at each other's throats because there were just different tool chains in each, right? There's sort of the Hadoop, I think they had written a bunch of stream sets works. They had a Connectica database in the cloud. They had ADSL, Azure Data Factory. And so the tool chains were different on each side. And so how do you get these teams to work together? And so being able to actually orchestrate across the clouds and run tests on each side of the movement, to be able to say, okay, I've got my stream sets work, I've got my Hive schema, I'm actually checking the schema, I'm moving it to Azure Blob Store, I'm putting in SQL Server, I'm checking schema drift, I'm checking semantics of the data, size, shape, row counts, and then being able to work and meta orchestrate across all these different tools, and then be able to deploy this from dev into production, and be able to roll back when something's wrong. And so, it sounds like a really dumb case, right? You got two different people, two different groups, they're sharing data, things are breaking left and right. But it actually goes to a very important design principle that you've got a bunch of tools on each side. You've got data flowing between two systems, and you just want to make sure the data's right. You want to make sure it's checked. You want alerts if there's problems, and you want to be able to do that. You've got to orchestrate across all these tools, and then you've got to be able to fit in the development process, because this isn't a house that you build. It's sort of a river of change, and the Texas team and the Azure team are kind of constantly adding new features independently of each other, and so. That was successful. And what this group has decided to do is to take that idea one step further and sort of create a core capability across the organization, kind of a core, what they call a hybrid self-service DataOps platform. Because that case between the Texas team and Azure is one case of many where you've got one team working in one way and another team working in another. They've got teams working in Amazon as well as Azure. They have multiple on-prem environments. And like a lot of organizations, they've got a lot of tools that they want to use, like Equalium or StreamSets or Python or Airflow that they like to do their data work in. And people love their tools. And so different groups have chosen different tools. But how do you actually get them to adopt the principles that we talk about with DataOps? So the first thing that they've done is sort of built with DataKitchen a sort of core DataOps technical platform. And then they're also working on kind of a set of services about how do you transition a team to work with DataOps? How do you actually get them to adopt across a large global organization across the world, multiple tools, multiple teams, multiple locations, to be able to adopt these principles? Because I think what they realize is that their current way of working is just either is too risky, or too slow, or both. And so they're trying to both roll out a core platform and develop sort of a set of DataOps transformation services. And the third case I want to bring up is more of a financial service company, and is like, how do you actually make this happen? So how do you actually bring up, take a large global multinational company and how does the CDO or an enterprise level data office actually make this change? And if you look at it from a big company standpoint, like there could be banking or high net worth or insurance, and each one of these has their own sort of data and analytic function. Maybe sometimes they're aligned to a CIO, but sometimes they're largely independent. Sometimes they have their own databases and their own tool chains. And here you've got the CDO office who said, wow, we think this DataOps thing is we're in our CI office, we've done a DevOps transformation. We should do a DataOps transformation across all our data and analytic teams. And so how does that work in sort of a largely siloed world where each one of these teams operates independently? And so, I think one of the biggest things is, how do I influence these teams? How do I get them to adopt these ideas, adopt technology? And largely because we all know technical people, they're gonna smile at you if they don't believe in you, and just go on and do their own merry way. And so how do you express the sort of complex horizontal influence to make DataOps happen? And so, we've actually started to talk about how you bring DataOps kind of to large enterprises like this, right? How do you actually educate different teams? How do you find and establish, how do you find specific projects, demonstrate values, establish communities across each one of these divisions, and then iterate and expand? How do you apply the idea of iterative development to an iterative rollout of a DataOps capability? And so those are sort of three examples of how people sort of do DataOps in the cloud, and how they brought DataOps across multiple clouds in large organizations. And so in summary, I think, there's a bunch of gaps in sort of DevOps and workflow tools that are in the cloud. And you may be tempted to build your own from those tools. And our recommendation is to stop. I guess we've just seen too many companies kind of hoping to achieve rapid development times and low errors and end-to-end collaboration, just sort of fail at it. Like I said, a few unit tests in development, up some glue code around talent, it doesn't end up not working. And so our feeling is don't apply the sort of patina of software development focused DevOps tools to your more complex data and analytic projects. That's why DataOps is becoming a thing. And I think that's where our software comes in. And so if you are looking to do this and looking to solve some of these challenges, we have some software for you. And so we have a DataOps software platform that focuses on these very things and solves these problems that we talked about in this presentation. And if you're still a bit on the fence, or if you're from Missouri, which happens to be an American phrase, meaning you're still a bit cynical, we've actually written quite a bit about the ideas of DataOps. We have a free book, a 200-page book in its second edition that we've given out 10,000 copies. If you only don't want to read a book and just want to read 18 points that talk about DataOps, we have a manifesto. And so these are two good points to learn more about DataKitchen and DataOps. And so that's all I have for today. Let me see if there's any questions that need to be answered.
Thanks very much, Chris. If you don't mind stopping the sharing, and we'll return back to the video screen.
All right.
Yes, so thanks very much for that. It was a great presentation. We've got a few questions. I've got a few questions myself. I've had a few questions from the audience as well. First things first is if people could see the attachments there, there's links to our next couple of webinars coming up. So if you enjoyed this, then do come along. First question's easy. Can we get a copy of the presentation? Actually, this session will be on demand instantly after we finish. So if you want to go and watch bits of the presentation again, rewind and pause and take in specific bits, you'll be able to do that from this link. Second question is a good one, actually. So what's the difference between DataOps and MLOps? So lots of ops, lots of acronyms, and obviously it can be a bit confusing because there's lots of terms being thrown up. Are they the same thing? Are they different? Is it subtle? Is there a subtle difference? Is there a complete difference?
Yeah, well, okay, so there's two things. There are sort of differences between DataOps and MLOps. I guess I look at it in a kind of a long-term view. So, I grew up in the central part of the United States. My dad was in a union of telephone repairmen. And back in the 1980s, Japan was actually America's biggest fear because the Japanese were making much better cars. And a few miles away from my house was there a company called American Motors that made just a terrible car. If you remember the AMC Pacer, it sort of lasted 50,000 miles and rusted out. And my dad bought a Toyota Corolla like in 1980, and he said, "This is an awesome car. It's cheaper, it lasts longer, it's better." And he took a lot of crap from his union guys. And so, like, why did American Motors go out of business, and why did Toyota go on to be the biggest car manufacturer in the world? And I don't think it's because, the Japanese are smarter, or, I remember reading an article about American Motors installing a bunch of robots, and that was going to be the savior. I think it's because Toyota focused on the people and process of how they make cars. They developed something called Lean, the Toyota production system. And that, instead of focusing on let's buy a better workstation or a better robot, let's get all of our people to work better together with the tools that they have. And so sort of play those ideas forward. And some people in 2001 wrote the Agile Manifesto, and then 2009, sort of DevOps came along, and those ideas actually transformed and applied to the same ideas, started to get applied to software. And so whether you call it data ops or model ops, the same ideas are being put into data and analytics. You got a technically complicated thing, you got a bunch of people working on it, the same principles apply. And so from one standpoint, the ideas are all sort of just walking their way across industries. And so I happen to think that sort of those principles are what's important, and coming from Deming or Lean or total quality management. And so I do think that sort of data ops and model ops they have some differences, but they're very similar in spirit. And so, I just think I'm just happy that anyone's talking ops at all, and that there's even other ops out there. Like we've seen a lot of things around data GovOps, like data governance operations. So watch out, more opses are coming around the corner.
I'm going to rephrase my next question then on the basis of this. So the original question was going to be: do you think that people, obviously DevOps has been around for a long time, is quite widely widely implemented across a lot of organizations now. I was going to say, do you think it's a help or a hindrance if a company is very DevOps indoctrinated, given the difference between DevOps and DataOps? But I'm going to ask you, what should people look out for if there's a lot of DevOps in their company and they're worried that the DataOps implementation isn't going to go, is just going to be, it's going to be DevOps and they're going to miss the point, kind of thing?
Well, I actually think it's fantastic if they have a successful DevOps rollout, right? Because you've got people who sort of get it. And what I found, but like back 5 years ago, when we started going to conferences, I'd wear a chef's hat and give out wooden spoons, and I'd talk DataOps, and no one knew what I was talking about. But every once in a while, there'd be someone who'd like gone from software engineering into doing data engineering or data science. And it's been given my 10-minute spiel, and he'd go, aren't you just doing DevOps for data science and analytics? And I go, exactly. And so I think it's, once you sort of get the principles, it's great. And so, I think I think some of the, and sitting around the lunch table, having your data engineer saying it takes, me 2-3 months to deploy my SQL, and the guy saying, oh yeah, here, I'm just going to press and do my deploy on my phone in 1 second to my new JavaScript. I think there's some shame that can cause some change. And so, and I also think the transformation, especially in larger organizations where they've tried to educate and change people's behavior, I think that's a good model. So actually, I'm really excited when there's an active DevOps team because it gives an opportunity for DevOps people to learn a new domain. They're already familiar. They're already sort of bought into the agile mindset, and I think it's I think it's happening in a lot of organizations now, where they're starting to realize that these principles need to apply to the data science and analytics world.
Okay, perfect. Good. Well, next one's going to be people. So I'm setting off on my DataOps journey. Do I need some new people? Do I need some different people? Or are the people I've employed with a new tweak and a new indoctrination going to be okay? Or does it depend? I guess I'll give you the chance.
Well, it's a bit of an indoctrination, I think. I think of it, instead of people, I think of percent of time. And so one of the things now is that most people they spend very few, less than 1% or 2% of their time developing automated testing of their data, of their models. They spend 1 or 2% of their time on automating deployment, automating environment management. So the things that you're doing over and over again, script them, automate them, write tests. And that should be everyone's job, right? And you could call that data ops or model ops activity, fine, but like that should be the job that people do. And then second is sort of a change in behavior, like when you have problems, and everyone who has data has problems, right? And don't blame someone. Sit down and make a list of your problems, and then try to find patterns in that list and fix it. And so I think you can start applying the principles of data ops today through automation, through automated testing, through quality circles. And I do think there's an emerging role of a data ops engineer who's focused on this. And I think it's like a DevOps engineer is actually probably going to be one of the most sought after skills in the next 5 or 10 years, just like in DevOps. Right now you hire your typical Python or Java software engineer, and you got to pay sort of 5 or 10% more for a DevOps engineer because they're just in demand. And so it's actually how you get the team to work together with all their tools. Software engineers have realized or the software teams have realized that's a really important skill. And it's good people like that are force multipliers, and that's why they're paid more.
Yes. Yeah. Okay. Someone's asked a question. Good question. I'm going to just slightly reword it. Because I was going to ask about sticking points with this. So they've asked how central the mindset transition is with all this. What's the biggest sticking point? Is it the mindset change for people, or is it a technology thing, or what typically with your clients? What's the thing that the first important hurdle?
I'm pretty believer in that. You got to believe in the principles, right? If you don't believe in the principles or the mindset, it kind of doesn't make sense. And so, And to do that, you've got to have suffered for a while and seen the lack of those principles. So I'm a believer that the mindset's first, and I believe right now it also comes from having leaders in your organization say this is the way that we're going to go. And so I also think it's, it is sort of what that mindset, you could argue it's a religion, right? But that's, but I think some people have to do the religion and do some of the rituals in the religion itself. So people have to be able to do it. So there is technology like our product to support it that people need to do and get on. But I think it starts with the principles, and once you work your way back from those, I think that's where people should start, and that's why we wrote the manifesto, why we wrote the book. It's a way to get people to believe in those principles.
Perfect.
Can I add one last thing before? I think,
yeah, of course.
Yeah, deep down, I think a lot of people who have experience in data and analytics recoil at the thought that you can change things fast and not have problems. Because a lot of very fragile data and analytic systems have been built, and they've taken a lot of blood, sweat, and tears, and they get in production, and then nobody wants to change them because they're afraid. They're like, oh, something's going to go wrong. And then, or they build something really complicated, they're really smart, and then they patch it for months and years afterwards, and 80% of their time is maintenance. And so when someone says you can change things fast and you can have low errors, there's a cynicism that's involved in that, because people don't. And so I think, I think partly is trying to unwind that. And actually, the studies have shown that best performing organizations do everything well. They deploy fast. They run with low errors. They have a lot of collaboration, and trying to shoot for that as opposed to the belief that it's never going to work.
Perfect. Well, I'm going to make this one the last question, and it's kind of about higher up in the organization. And I would have loved to have got your opinions on organizations that have a dedicated sort of data person on the board versus other structures, etc. But for the benefit of the people who are watching, I thought it might be interesting to ask, what's the best way of justifying this or explaining this to people higher up who are going to need to invest in it? Obviously, we get the technical and the process stuff on the data side, but if you're explaining to the person who's going to fund it, the advantages, the benefits, the ROI, what's the best tack to take?
Well, there's always the emotional fear, right? Fear that you're going to get beat by your competitors, because the Silicon Valley companies have that. A lot of ways they've put agility at their core, right? And they do everything agile, right? Software, marketing, and data and analytics. And so that's one. And everyone's afraid that Amazon's going to take their business away. So there's also FOMO, the fear of missing out, right? That this is DataOps is taking off, and our near competitors in our vertical are going to beat us to it. And then, I think there's sort of another F word, which I'm not going to mention, is that a lot of organizations screw up, and they screw up repeatedly, and they waste millions of dollars. And so there's not much else you can do when you've done AI and ML and big data and data science and moved to the cloud. You've gone through all the cool new acronyms, and you spent millions of dollars on a bunch of tools that have either sat on the shelf or not used. And you got to start focusing. There's nothing else you can do. And you got to start thinking, well, maybe it is a people and process problem and not just a technical. I talked to an organization, they spent £100 million and threw it all away. And they're on their third generation of infrastructure. And they finally realized that it's a people and process problem. They put that first and put the infrastructure second. And I think that's so I think that's, it's fear, FOMO, and another F word I won't say.
That feels like a brilliant place to wrap things up. And thanks very much for your time today, Chris. Please, everyone, go out and check out DataKitchen and the manifesto and the cookbook on their website. And pleasure having you on. And we'll speak very soon, I hope. Yeah.
All right. Thank you very much. Have a great day. Bye.
Yeah, you too. Thank you. Bye-bye.